Welcome to another SPSS tutorial for class. We're going to be using the data from Lomax and House Vaughn. You can check out the data in your textbook or you can download it from our website. We're going to be focusing on Factorial ANOVA, but just to get us sort of reoriented in SPSS, as an introduction, we're going to go back over these data, and we'll initially start with a very quick version of a one-way analysis of variance. So if you recall from before, we had this group variable. This is our first independent variable, and it represents the attractiveness of the statistics lab instructor. So we can go back under variable view. We can see them here as well. And we know that 1 through 4, 1 being, in this case, would represent unattractive, and 4 would be attractive in this case. We also have a second variable now. This second independent variable is time, and it represents afternoon or evening. So we just have two different time periods someone could attend these classes. And then we have our lab outcome, the actual number of statistics labs that a student attended. So group, time, and labs. All right. Previously, before, we've done one-way analysis of variance two different ways. I'm just going to do one of the ways just as a reminder. Under compare means, you could do a one-way ANOVA through compare means, but because we're going to extend this to the factorial model, we're going to go back to the general linear model. Under the general linear model and univariate, I'm going to go ahead and select that, and our dialog box will pop up. And as a dependent measure, we're going to use labs. That's the number of stats labs someone attended. And we'll go back and just use groups as our fixed factor. If you remember, under options, there's several options we can select. We like to see descriptive statistics. That gives us an idea of our means and standard deviations, our estimates of effect size. In this case, it should be eta or partial eta squared. We'll see in a moment. We went over the calculations for that in class, and it's in your text as well. Observed power, our chance to find a difference, when a difference really exists. So when we're looking at observed power, we want to know what's our chance, what's the probability that these differences would occur given things like effect size, significance level, etc. We'll go ahead and do a homogeneity test. It's nice to see Levene's test again, and our spread versus level plot. I'll go ahead and click that. I'm not going to go through all of these for the one-way factor analysis. Our one factorial, we're going to go over for the factorial model, not for the one-way ANOVA. But I'll go ahead and click on them now and then come back to them in a moment, and so you've seen it multiple times. And under post hocs, I'm just going to go ahead and pick Tukey's test. For now, I'm going to go ahead and leave that. Remember, some of our tests in here are more useful than others. Refresh your memory by using our charts in our textbook and also reading through our text chapter. Our one-way analysis of variance chapter information will be relevant here for our factorial model. But another really good option, if you want to be on the more conservative side, is the Scheffé test as well, because it will always be consistent with that F value. I'm going to go ahead and click continue. And I'm going to click OK. I'll come back to some of the other options in a moment. So the idea here is just to give us something familiar. I'm not going to go through all of these. There's another video on this. We know Levene's test is significant with ours. We can see that those standard deviations are relatively close to each other. Test of between group difference, we see that we ended up with the same F value we had in our other video. So we're sort of back to our one-way analysis of variance, and we're just going to extend this model. We also got multiple comparison tests for Tukey's test. We've gone over this both in class and a previous video. We see things like there's a significant difference between group 1 and group 3. And that's our quick version of our one-way analysis of variance. Just to situate us on what the extension is. So now we have two variables we care about. We went through, we calculated this out. We got a significant value for our we got a significant F value for our group difference, but we want to know about time. We think that in this example that time may also impact the outcome, not just attractiveness. So in our univariate model, we're going to take time, afternoon and evening hours, and we're going to put it in as another effect. A couple things are going to happen in our model. I'm going to go ahead and go to Model. And if you notice under Model, there's a lot of things already set as default. The specific model, full factorial model, is set as default. We have intercept checked off, and we have type 3 sums of squares. In our factorial model for analysis of variance, and even in our one-way ANOVA, this is what the default is in SPSS. The type 3 sums of squares is very useful. It effectively partials out our effects very much like a regression model. We'll talk more in class about types 1, 2, 3 sums of squares, maybe even throw in type 4. But just so you know, so you've seen it before, you could also customize a model. And I'll go over this later on in the semester. But just sort of showing it to you now, just so you know that you can customize interactions, main effects, and all sorts of two-way, three-way, four-way models. The full factorial model automatically does everything for you. So I'm going to go ahead and click Continue. And that's also to allude to the fact that we're going to be testing the main effect of group, the main effect of time, and the interaction of group and time on labs. We talked about this in class. So we're going to end up looking at 3 different F values. We're going to look at the effect of group, holding time constant, the effect of time, holding group constant, and then whether or not those 2 effects are independent of each other. And that's what we're doing in the interaction effect. So under options, I'm just showing you these again. We've already clicked off those ones that we want. We're going to leave them as they are. Under post hoc procedure, I've already clicked Tukey's test. I could click a few more if I wanted to, but usually I would just recommend using one post hoc analysis, thinking through it. Even if you're going to use a post hoc comparison, I often think through these as if they were planned comparisons, think through which one I want to use and why I'm using it. So in this case, Tukey, I want to see all of those possible comparisons with the Tukey test. Under plots, I want to see the plot of group on the horizon and time on as our separate lines. I'm going to go ahead and click Add. Now I'm going to get a plot of group by time. Go ahead and click Continue. In class, I mentioned to you plots are some of my favorite ways to explore interactions and look at the data. So often I want to be able to see whether or not the lines are converging toward each other or crossing or diverging somehow, which tells me whether or not there's an interaction effect. All right, I'm going to go ahead and click OK. We get our new model. Our descriptive statistics, as we saw from class, just to go over this again, we see that they're broken up. We can see that they are broken up first by group, 1, 2, 3, and 4. And then with each group, there is a time, 1 and 2. Group 1, time 1, is like cell 1. We know for those participants that were in group 1 that attended time 1, the afternoon time, had a mean of 15.25. And those that were in group 1, time 2, had a mean of 7. So there's certainly a difference between those two within group 1. We can see that the average between those two was 11.125. That's the average overall for being in group 1. So this is the cell level, group 1, group 1, time 2, and this is like the marginal across those two. And we went over that in class. That's sort of just as a refresher. And this is the grand mean. The total at the very bottom is the mean of being in anything in any group across all of our times. We see again that the Levine's test is 0.76 up here, right here, and that is good to go. And we can also, I often just kind of eyeball the standard deviations. There's some differences going on, but in this case, they're good enough for us, given Levine's test. And now we have our test of between effects. In class, we talked about the fact that we're going to skip a couple of these F values, that even though we counted them out in class, 5 F values, we really care about 3 effects: the main effect of group, the main effect of time, and the interaction of group by time. Here's group, here's time, and here's the interaction of group by time. Also, you don't see within here, but you see error. In class, we have talked about the denominator, the error term in our fixed effects model as our mean squares within, or often our mean square error. We use those synonymously in this class and in our textbook. So we know that we would have had to take the error term here of 11.531 and divide it in time by time of 712.531 to get that value of 61.79. And that's significant. And we look at time and we look at group, and that F value here, if you see that F value, and that is significant as well. The group by time interaction is not significant. It is a 0.602. So it is not significant. It's well over our 0.05 value that we typically look at for significance levels. And just to say a couple things about that, the first thing is that if it's not significant, that means we don't think there's an interaction effect between group and time, that these things are independent of each other, which is good in the sense of the main effect of F. It makes it easier to interpret the main effects of F. We can see that the main effect of group and the main effect of time are both significant, and it's not entangled with this idea of an interaction, which means the interpretation of these are easier. And we'll take a look at the interpretation when we look at the graph in a moment. We also see partial eta squared. This is our effect size. We could interpret this a little bit very similar with partial eta squared, very similar to our R squared value. So we see that 0.727 and 0.720, those are relatively large effects, whereas the group and by time interaction, a very small effect going on here. Also observed power, these are effectively 1 for both group and time. That means given the effect and all else, we expect to find those differences with these differences in the means. Multiple comparison procedures. I ask for 2 keys, and we look here, and we look around. We only see one set of comparison procedures, very similar to what we saw last time. In this case, though, one of the reasons why you only see this reported for group is because for time, there's only 2 times. So if there's a significant difference in time, we can really just go look at the raw means to look at what that difference is. So here we see some significant effects. We see a significant effect of 1 by 2, 1 by 3, and 1 by 4. And then we see 1 by 2 repeated here. We see 2 by 1, repeated here. It's the same as 1 by 2. And then we see 2 by 3 is not significant, and 2 by 4 is. So you can go through these effects and see whether or not each one of those is significant given this new factorial model. Remember now, one of the differences here, when you look at this set of multiple comparisons, we go back up to our multiple comparisons group up here, look at the standard error here of 3.00465. This is because we're using the standard error is impacted by our error term in our analysis of variance, and we can see that in this model we now have a different error term. So this will change our group comparisons. So I'm going to go ahead and skip down to our graph. In our graph, our estimated marginal means table really tells us a lot of information about these means. They're plotted in space. We have across the bottom our group 1, 2, 3, and 4, and the 2 lines that are separated in space here are time 1 and time 2. This is a visual representation of our data, And one of the great things here is that we can see things not just for main effects, but for interactions. The first thing that probably jumps out to you is that there's a big gap between these two lines. That big gap represents the main effect of being either at time 1 or time 2. So if we wanted students to attend more labs, we would certainly want them to be under time 1 over time 2. The next thing that maybe jumps out to you is that there looks like there's this effective linear type effect that as you go from 1 to 2, it increases, from 2 to 3, from 3 to 4. We have a sort of increasing model. So we know that there's also a main effect of group. This is from unattractive through attractive. But we don't really see much of anything converging together, like these lines aren't starting to cross over each other, or diverging, that they're splitting away. So we would not say that there is an interaction effect just visually looking at this data. For now, I think I will stop this video since it's gone about 16 minutes at this point, and I will come back to some of these ideas either in class or in another video.